just he has brought again, once again, the idea of photoelectric effect. There's a positive terminal, so it will produce electric field like this. So this particular ejected electron, it will have kinetic energy K. By the time it reaches here, it will have kinetic energy, say K1. So what is K is equal to HF HC by lambda SC by lambda minus work function. And what is K1? K1 should be equal to K plus 5E. 5 electron volt it is. Because the accelerating potential will accelerate the charged particle. This particular thing is incident on the electrons pass through all A into the gas of hydrogen in the ground state. Find the number of spectral lines emitted when hydrogen atoms come back to their ground state after having been excited by the electrons. I think somehow we should, 5 electron volt is there. So this will calculate 1240 by 1242. 12, okay, SC by lambda. Work function 2 electron volt.
12420, sorry, numerator.
420. So how much you'll get? This 8 electron volt. But what happened? It's not that only 8 electron volt. So the emitted electrons will be how much? It will be 0 to 8 electron volt. But the kinetic energy, of photoelectrons ranges from 0 to 8 electron volt. Will I agree this? So what will be now the energy of the electrons that will enter the OLE? So this will be 8 electron volt, 5 electron volt. Will go for this is 13 electron volt. So this is not the only energy. So the energy of the electrons entering the hole will range from 5 to 13 electron volt. Okay, the kinetic energy of electrons entering the hole ranges from 5 electron volt to 13 electron volt. Okay, now I think 5 electron volt not possible, no? So to what excited levels it can take there. So what are the some 13 between 13 and 10 is what I should pick up, no? For excitation.
Up to n equal to 4, sir.
Up to n equal to 4. I think even if you know the differences, energy levels, you'll be on safer side. First 10.2 possible. Next, the difference will be 12.09. One more will come.
12.74.
12.74. Okay, the difference will be delta E1 to 10.2, delta E1 3 12.09, or approximate 1 will write it. Delta 1 2 or 1 3 or okay 1 4 12.7 4. Yeah, okay. Shall we say only these electrons, only for the hydrogen atom will interact with only this? What type of collision it will encounter? The hydrogen atoms, what type of collision it will encounter with electrons whose energies are not equal to this much here? So let's take 12 electron volt. It will undergo elastic collision. Or it will absorb how much needed? 12, it's like an electron coming with 12 electron volt. What happened? It will absorb 10.2 from here. Remaining the electron, what happened? Will take back and go. Is it like that? or the gas, hydrogen gas will interact with only those electrons which are having these energies. Anybody wants to answer?
First is correct.
I'm unable to hear.
First is correct, sir. First statement.
Will interact with only these electrons.
No, sir.
No, it will interact with all electrons. How much needed for transition it will take up. The if electron, if it having energy, any residue, anything left or no, with that energy, what the electron will go back. Or will be scattered. What will be that? Let's not bother that one. So what we can say that one, the hydrogen atoms will interact with only electrons which will possess some specific energy like 10.2, 12.1, 12.74. Or will it interact with all electrons having energy 5 electron volt to 13 electron? Yes, it will interact. Those which are having 5 electron volt, anything less than 10.2. What is the problem with them? Elastic collision. Am I right? Those electrons with 10 electron volt. So they'll come, they collide. So the hydrogen atom will not accept any energy and the electrons will just get scattered with 10 electron volt. Those which are having energy more than 10, say like a 10.5, those which are having 10.5 electron volt, the hydrogen atom will take 10.2 from the electron, the remaining 0.3 will be given to the electron. And the electron with that energy will get scattered. There's a very important statement again. So what we should say, it will interact with all. But what is the nature of collisions? Few will be elastic, few will be inelastic. Those which are having energy less than 10.2, less than or equal, or say like a less than 10.2 electron volt, it's elastic. Those which are having more than 10.2, more greater than or equal to 10.2 will be inelastic. I think that you have to be just now neutron we discussed, no, the similar thing. Okay, now we can go for the transition. So this will be one photon. Find the number of spectral lines. Number is asking 6, we can write it. Okay, we'll write it. Kinetic energy of electrons less than 10.2 electron volt. Elastic collision. Kinetic energy of electrons less than or equal to, you write it, in elastic collision.
Elastic can also take place now, sir.
Which one?
In second case, elastic also can take place.
How elastic, how
Elastic will be possible for all, no, sir, for all
Sir,
energy.
elastic will be possible for all.
first one or second one you mean to say?
Both.
See how the hydrogen atom will get energy.
If it doesn't get, sir, there is no compulsion that if an electron more than 10.2 electron volt is hitting it, then it should get excited.
See, probability we are talking, no?
Yes, sir. So there is a probability that there will be elastic collision with more than 10.2 electron energy, also, electron volt energy.
It may share, may not share. So if it shares, okay, we'll say that one. But this is for sure, no, the first case. In second case, what happened? Like a only one which will interact with where the if the atom gets de-excited, the electron what happen will be inelastic. Okay, we'll write both. Okay, there'll be more justified one. May inelastic, may elastic will write, or inelastic elastic. Let me put it.